Imagine for a moment that you pick up any piece of wood, one you have around the house, perhaps from an old piece of furniture or a fallen branch in the garden. It seems pretty ordinary, right? Soft, brittle, nothing special. But what if I told you that that humble piece of wood can be transformed into something stronger than steel? What if I told you it can become stronger than aluminum, lighter than titanium, and at the same time, more sustainable than any material we've ever created? You might think I'm exaggerating, that it's impossible for something so common to compete with the most advanced materials of our time. But the evidence that has emerged in recent years points to something revolutionary. Scientists have discovered how to unlock hidden potential that has been waiting under our noses for millennia. They've dubbed this material superwood, and although it may sound like science fiction, we may be witnessing the next great leap in the history of materials. A breakthrough that could change not only how we build our cities, but also how we explore the stars. Join me today on a journey to the heart of matter, where we'll discover how a material our ancestors used to make fire may become the key to our future. Throughout history, certain materials have defined entire eras of humanity. Bronze brought us out of the Stone Age. Iron forged empires, steel built skyscrapers, and connected continents with railways. In the 20th century, silicon launched the digital revolution, while plastics infiltrated every corner of our daily lives. Each of these materials had something in common. They were the result of complex, expensive processes that required extreme temperatures and enormous amounts of energy. But what if there was another way? What if nature had already created the perfect structure and we simply couldn't figure out how to activate it? That is precisely the paradox that has obsessed scientists for decades. Because it turns out that wood, that material we have taken for granted for millennia, hides secrets that we are only just beginning to understand. To understand what makes superwood special, we have to zoom in down to the molecular level. Imagine if you could shrink down to the size of a molecule and travel through the interior of a piece of wood. What you would see would be fascinating. Wood isn't just wood. It's an incredibly sophisticated engineering structure, composed of three main components working in perfect harmony. First, there's cellulose. If wood were a building, cellulose would be the steel beams. It's made of long chains of glucose molecules, intertwined like microscopic steel cables. In fact, fiber by fiber, cellulose is stronger than many metals. Then we have hemicellulose, which acts like the mortar that binds the bricks together. It connects the cellulose fibers to each other, giving the structure flexibility. And finally, lignin. This is wood's natural glue, the adhesive that holds everything together and protects the structure from decay. Together, these three components create a material that is strong, flexible, and surprisingly resilient. But here comes the interesting part. They also create limitations. Because it turns out that those same components that make wood so versatile also hold it back. Lignin, for example, while protecting wood, also makes it heavier and less dense than it could be. Hemicellulose, while providing flexibility, also introduces weaknesses into the structure. It's as if nature had created a superhero, but kept him asleep for millions of years. And how do you wake up a giant? The answer came from an unexpected place, the laboratories of the University of Maryland in the United States. A team of scientists led by Professor Liangbing Hu was investigating ways to make materials more sustainable when they stumbled upon something extraordinary. They discovered they could reprogram the molecular structure of wood, not through magic, but through a two-step process that combines chemistry and physics in a way that nature had never attempted. The first step is brutally simple. You take an ordinary piece of wood and boil it in a solution of caustic soda and sodium sulfide. If this sounds familiar, It's because it's practically the same process used to make paper. But here, instead of turning the wood into pulp, we're purifying it. This chemical treatment does something fascinating. It selectively removes the lignin and much of the hemicellulose, leaving behind a nearly pure cellulose structure. It's as if we were removing the mortar and glue from a building, but keeping the steel structure intact. The result is a whitish, more porous wood that appears even more brittle than the original. But that's only the first act of this transformation. Because then comes the second step, and this is where the real magic happens. That chemically treated wood is placed in a press. But it's not just any press. Enormous pressure is applied, while it is gently heated to about 100 degrees Celsius. What happens then? The cell walls, weakened by the chemical treatment, begin to collapse under that immense pressure. But instead of destroying the structure, something incredible happens. The cellulose nanofibers compact and form new chemical bonds between them. It's as if millions of microscopic wires intertwine and fuse, creating a network of a density and strength that nature had never achieved on its own. When that process is complete and you remove the sample from the press, what you have in your hands is no longer wood. It's superwood. And the numbers are simply mind-boggling. Superwood occupies barely 1/5 the volume of the original wood. It has been compressed so much that its density has increased 5-fold. But its strength, its resistance, has increased 10-fold. Its ability to withstand compression, 50-fold. Its stiffness, almost 20-fold. To give you an idea of what this means, if you take a superwood beam, the thickness of your thumb, it can support the weight of a small car without breaking. It's twice as strong as structural steel, but it weighs less than aluminum. And here's the best part. It's cheaper to produce than either of those metals. Researchers in Maryland have calculated that the manufacturing cost of superwood is approximately 30% lower than that of steel and 50% lower than that of aluminum. Do you realize what this means? It means we can start rethinking how we build everything. Imagine 30-story buildings built with superwood, lighter, more earthquake-resistant, and with a minuscule carbon footprint compared to steel and concrete skyscrapers. Imagine bridges that can support the same weight as steel ones, but are built in half the time and at a fraction of the cost. But it's not just about large-scale construction. Think about the automotive industry. Electric cars have a fundamental problem. Batteries are heavy, and every gram of extra weight reduces range. What if we could build superwood bodies, lighter than aluminum, stronger than steel, and they would also absorb CO2 during production instead of generating it? Or think about wind turbines. Those giant wind-capturing blades could be made from superwood, making them more efficient and aesthetically pleasing than current fiberglass ones. The possibilities are literally infinite. But let's come back down to Earth for a moment. Because all of this may sound very nice in theory, but does it work in practice? The answer is, we're about to find out. Researchers at the University of Maryland haven't stayed in the lab. They've created a company called Inventwood, which has secured more than $50 million in funding. $20 million of those dollars came directly from the US Department of Energy. That tells you the American government is taking the potential of this material very seriously. And for good reason. According to their plans, Inventwood will begin commercial production of superwood in the coming months. They're going to start with relatively simple applications, building facades and structural beams. But if they're successful, if they prove that superwood can work in the real world on a large scale, we could be witnessing a new era in materials. Of course, as with any technological revolution, there are questions that need to be answered. Can Inventwood really scale production while keeping costs low. Processes that work in the lab don't always work in huge factories. Will Superwood deliver on its promises when faced with real-world conditions? Hurricanes, earthquakes, decades of exposure to the elements. And then there's the million-dollar question. What about sustainability? Because yes, wood is a renewable resource. But what if suddenly everyone wants to use superwood? Do we have enough forests? And what impact would that have on ecosystems? Fortunately, the numbers are encouraging. Superwood uses approximately 80% less material than traditional lumber to achieve the same strength. That means, in theory, we could get 5 times more useful material from each tree. Furthermore, wood itself acts as a carbon sink. Each ton of superwood stores approximately 1.8 tons of carbon dioxide that would otherwise be in the atmosphere. Compare that to steel, whose production generates more than 2 tons of CO2 per ton of material. The difference is abysmal. But perhaps the most exciting application of superwood is yet to come, because it turns out this material has some properties that make it perfect for something that until now seemed unthinkable: space exploration. Superwood is radiation resistant. It's lightweight, it's strong, and most importantly, it's organic. That means we could, in theory, grow the building materials for a lunar or Martian base directly in space, using hydroponic techniques. Can you imagine it? Astronauts growing superwood in orbit, then building space stations with it. It sounds like science fiction, but scientists are already investigating this possibility. As we look to the future, materials like superwood remind us of something fundamental about human progress. Sometimes, the most revolutionary answers don't come from inventing something completely new, but from looking with fresh eyes at something that's always been there. Wood has been our companion throughout human history. It has given us shelter, warmth, tools, or art. And now, it turns out it might also hold the keys to our future. A future where the materials we use to build our world don't destroy the planet in the process. Where strength and sustainability go hand in hand. Where what we need to reach the stars may already be growing in the forest next to your house. The next time you see a tree or touch a piece of wooden furniture, you might remember this story. And you might wonder what other secrets nature is holding, waiting to be discovered. Because in the end, superwood is more than just a revolutionary material. It's a reminder that the universe is full of extraordinary possibilities, and sometimes they're closer to home than we think.